All right, folks, today we're going to talk about ratios and proportions in geometry. Okay, so first up, we're going to define what a ratio is. A ratio just means a way to compare unlike or like things. Okay, so a method of comparing two or more items. And a lot of times this is represented as a fraction. Okay, but it can also be represented with a colon, and I'll show you both ways as we get through some examples here. So it says on number one, a running back scored 6 touchdowns in 14 games, and we're finding the ratio of touchdowns to games. So here are two items being compared here, and the ratio wants touchdowns on top and games on the bottom. So if we're looking through our given information, it said 6 touchdowns, 14 games. So we have to represent the first item on the top. So that's 6 touchdowns. And the second item on the bottom, 14 games. Okay, but the thing with fractions is we always want to reduce if we can. Even though these aren't like things, we can reduce our ratio with our numbers. So our 6 over 14, we're going to reduce to 3 over 7. We're just going to keep those labels attached. So 3 touchdowns every 7 games. Okay. But I told you that that's one way, and another way we can do it is with a colon. Just as an example, this word two often you see as a colon instead. So we could have written, and you don't have to write this, but I just want to show you, we could have written our final answer as 3 touchdowns, 2 using the colon, games. Okay, so fraction or as a ratio with this colon in between. Please do write above the word 2, that dot dot, because you will see that, and that's how we read it out loud. All right, the next one. In a schedule of 10 classes, Marta has 2 elective classes. What is the ratio of elective to non-elective? So elective to non-elective. Those are the 2 items we need to compare. Sometimes it's helpful to actually put those labels first. So electives are what we want on top, and non-electives on the bottom. And then we can attach the number after the fact. Okay, so it says a schedule of 10 classes, 2 elective classes. So this one definitely says elective. That 2 can go on top. Okay, but this 10 classes doesn't specify that that's the non-electives. This is your total. Okay, so if that's our total and 2 of them are electives, that means there's 8 left over, okay, to be non-electives. We just took 10 minus 2 here. Okay, but again, we're going to reduce because we're dealing with fractions, so that's 1 elective, okay, to 4 non-electives. Now, one thing that's different here with regular fractions, we do have to always include the number 1. We can't leave it off like sometimes we do with if that one was in the bottom. Okay, we do have to write a number with our labels here. All right. We're going to now talk about how these ratios can be used to solve for unknown values in geometry with pictures. So we've got a diagram here. It's a segment, and it says AB, remember this means 2, AB to BC is 4:1 as a ratio. So what we're going to do is on our picture indicate that ratio with what we know. So AB goes with the 4 and BC goes with the 1. So with the AB on the picture we're putting the number 4. With the BC we're putting the number 1. But it says our total length AC here is 30. Well, 4 plus 1 doesn't give us 30 because there's some factor that was reduced just like we had on those last ones. So to find that working backwards, all you have to do is put an X on both of those, and that X is representing our factor. And as we set this up, very similar, we're still going to add them together, but we get 5x instead of 5, and 5x can be equal to 30. Then we can solve for x by just dividing that 5 over, and that's our factor of 6. Okay? Well, with that in mind, it wants us to find the actual lengths of A, B, and BC. They're not just 4 and 1, it's 4 times that 6 value. Okay, so let's write that out. AB is 4x, but that's 4 times 6 is 24. They didn't give us a label on that 30, so we're good there. And then BC in our picture was 1x, and that's just 1 times 6 is 6 itself. Okay, so we've got lengths of 24 and 6. If we put that on our picture, it definitely gives us the 30 that we needed to have happen. Okay, let's try that again on the next one. EF to FG is 2 to 1. Okay, so EF goes with this number 2, and FG goes with that number 1, and it says EG from here to here is 30. Okay, but 2 plus 1 again is not 30, so we throw an x down. So now we've got 2x and 1x makes 3x equal to 30, and we can solve. Dividing by 3, we get x equals 10, and we want to use that to solve for our EF and FG. Let's write it out. EF on our picture was 2x, so that's 2 times 10, gives us 20. Again, they didn't give us a label, so we'll just leave it at that. And then FG was 1x, that's 1 times 10, which is just 10 itself. 20 and 10, going on our picture, gives us the 30 total that we needed. We can also use these ratios to determine in shapes what values could mean, so either the sides or the angles. So that's what we're working with on these next few here. It says the ratio of the measures of the sides of a triangle is 3, 5, 7, and its perimeter is 450 centimeters. Find the measure of each side of the triangle. So I want you to draw these out as you're given. So this thing is talking about a triangle, so our first thing we're going to do is draw that out. Okay, using your geometer will make it look a little bit nicer, but it does not matter which triangle you pick because we don't know what the angles are to start with. Okay, then it says the sides are these numbers. So on the sides we're putting 3, 5, and 7. Doesn't matter where you put them. Okay, but when we take 3, 5, and 7 and add them together, we do not get 450. It's talking about perimeter, so we're supposed to add up those numbers on the outside. Okay, but when we add them together, we get 15. Okay, that's because, remember, we have to put an x on each of these. It's times some factor. So then we can say 15x equals our 450. Dividing by 15, we have x equals 30. Okay, and that 30 is going to be used to find the measures of each side of the triangle. We've just got to plug them in. Okay, so we've got 3 times 30 is 90. We've got 5 times 30, and you're welcome to do this on your triangle itself if you'd like, is 150. And our last one, 7 times 30, is 210. Now, the reason I space these out is because I'm going to write my answer in the same formatting this one is, just with labels attached. So this perimeter was talking about centimeters, so I'm just going to put centimeters here with a colon, centimeters here with the colon, and then a centimeters at the end, and put a box around that for my final answer. Okay? Don't forget your labels on these word problems. All right, next up it says the ratio of the measures of the sides of a triangle is 5, 6, 9, and its perimeter is 220 meters. Okay, again, we're going to draw our picture. Okay, but this one is the same type of problem as last one. So I want you to pause the video and see if you can try this one out using your example from number 5. Alright, outside we've got a 5x, a 6x, and a 9x. Together it makes 20x, and that's supposed to equal 220. dividing by 20 on each side, we get x equals 11, which means my first side is 55 meters. My second one is 66 meters. And my last side is 99 meters. If I put all of those together, I get the 220 that I was supposed to start out with. Okay, something that is important to me though, you want to make sure, because this was going lowest to highest, that we end up lowest to highest in that same order when we're writing that as a ratio. Alright, this time it's talking about the angles of a triangle, and it doesn't give us any other number. Okay, so let's draw out our triangle to start with. We know that's happening. But because it says angles, we're going to go on the inside with these numbers. So we've got 3, 4, and 5. Again, we need to put an X on there because there's some value there that these are being multiplied that we don't know. Okay? But the reason they didn't tell us what to put it equal to is because we should already know. Okay, the angles inside a triangle equal 180 degrees. Okay, let's make a note of that. Okay, in general, we can always do problems like this. Sorry, I said 180, but wrote 360. Okay, we can always do problems like this because we know some of the shapes automatically. We know a triangle is 180. We know a rectangle, a square, any quadrilateral is 360. But in general, any shape, don't forget, we can take n minus 2 times 180 to get the measure of the angles inside a polygon if we need it. Okay, so you might jot that down for use on your homework. So, finishing this problem here, we've got adding these up, 5, 4, and 3 makes 12x. And then we just have to divide that 12 on both sides. And when we do that, we get x equals 15. Once we have that 15, we can go plug in for our 3 different angles. So 3 times 15 is 45 degrees. Doing that same thing for the next one, 4 times 15, that's 60 degrees. And lastly, 5 times 15 is 75 degrees. And again, just finish with a colon in between. Alright, next up it says the perimeter of a rectangle. So it's changing the shape on us. We're going to draw a rectangle out. But it says perimeter, so that means we're outside again. It says the perimeter is going to equal 84 feet, and the ratio of the length to width is 4 to 3. So length is 4, width is 3. Throw in an X on both of these. Okay, but if it's perimeter, we have to add up all of the sides. Okay, remember, if it's a rectangle, opposite sides are the same. So we can put those pieces on all of the sides there. And same process, perimeter, we just add them all up. So we've got 14x for this one. And we're setting it equal to 84. All we have to do is go solve that, divide by 14 on both sides, and x equals 6. Okay, once we have that, we can plug it back in for our 3 and for our 4. Okay, but remember, we want to write it in the order they give us. So 24 with the feet, colon, and then 18 with the feet. Okay, and those don't directly add up to the original that we were given, but remember, we actually have to add them up twice, and if you take your 24, 24, 18, and 18 and add them all up, you would get that 84. Okay. Alright, we're going to talk about proportions next. It's just two ratios split with an equal sign. Okay, so we've got a fraction on the left, fraction on the right. We've already used these this year, but we want to make sure that we remember the process of solving these so that we can do some word problems here in the next part. Okay, so remember when we're dealing with fractions in proportions, we can go ahead and cross multiply, but we always want to start with the piece of the cross that has the variable. So I'm going to go this one up first. We're taking 6 times x is 6x, and then we're going to do the other side of the cross. 3 times 8 is 24, and then we can solve that equation, dividing by 6 on both sides, x equals 4. Okay, same process on the next one. Okay, we're multiplying the part with the x first, so 7x equals, and then we're doing 126. Okay, dividing by 7 on both sides, and x equals 18. Okay, I want to show you another way to kind of think through these in terms of these problems that we just did. Okay, there's a relationship in the pattern of what's happening here. When I go put this 4 back in, I'm saying that 3/4 is equal to 6 over 8 because that's just a reduced fraction or a reduced ratio. If we look at this, to get from 3 to 6, you multiply by 2. That's the pattern. Well, so is 4 times 2 equal 8, the pattern on the bottom. Over here, 7 and 42, all I have to do is take times 6. So 3 times 6 should give me what I got for x, and it does. Okay, same thing here, but it's not as straightforward when you see this. We do know that times 2 is happening, so this should be half of what this number is. It should be 7. Okay, so let's work out the cross multiplication and test out that theory. So here, remember, if there's 2 pieces, we need to hug it with parentheses. So that's 10 times the quantity m plus 2. And then over here, we're taking 5 times 14 is 70. Okay, there's 2 ways to solve. You can distribute or divide. Okay, we often distribute, so let's go with that. 10m plus 20 equals 70. Okay, then we need to subtract that 20 over on both sides. 10m equals 50. Dividing that 10 over, we get m equals 5. Okay, so plugging this back in, 5 plus 2 is 7. We said it was supposed to be half of that 14. It sure is. Alright, there are 2 places with a variable on number 12. That just means it does not matter which piece of this cross you do first. I want you to pause the video and try that one out for me. Okay, so if I'm writing this out, 3 times y plus 2 equals 5 times y minus 2. We could have had either of these first. It did not matter. Okay, but distributing through is the way to go here. 3y plus 6 is equal to 5y minus 10. Then we need to get our y's together so we can solve. So subtracting this 3y over leaves us with 6 equals 2y minus 10. Okay, then we're going to add this negative 10 to get rid of it. And we have 16 equals 2y. Dividing by 2 on both sides leaves me with y equals 8. Okay, just to show you, 8 plus 2 is 10. 8 minus 2 is 6. 10 over 6 reduces to 5 over 3. It checks out. That's the whole idea of this proportion. Okay, so we can use proportions to solve for unknowns, and we're going to do it here starting with number 13. It says Brian is measuring plants in a field for a science project. Of the first 25 plants he measures, 15 of them are smaller than a foot in height. If there are 4,000 plants in the field, predict the number of plants smaller than a foot in height. So this is kind of like the first 2 problems that we had. We were comparing 2 unlike things, but we're going to do it twice, with one of those pieces being our unknown value. So we need to look through our problem and find 2 different labels that are happening. Okay, so it says 25 plants here, and it says 15 of them are smaller plants. Okay, so those are really our labels here. We've got plants, or total plants, and then we've got the small ones. Okay, and what we're going to do is set up a proportion, which means we've got a fraction on this side and a fraction on this side. Okay, first one, we're putting 25 with the regular plants, so that goes on top. And it says 15 of those are smaller, so the 15 goes on the bottom. Then it says there are 4,000 plants in a field. Okay, it doesn't say smaller plants, so that has to go with our total. And it says we want to know how many of them are smaller, so we put an X there. And now it's just like those problems up above where we just cross-multiply to solve. Okay, so we've got 25 times X. Then we're taking our 15 times 4,000. Gives us 60,000. Then we're dividing that 25 over to finish up. So it looks like 2,400 of them should be small plants. Okay, we're just going to answer the question in a little short sentence, or a little bit of a longer label there. But we want to make sure our answer makes sense. So here's what you're going to check out. Just going back to your proportion, we knew that the bigger number was on top here. We better make sure that when we're looking at this fraction here, our X is on the bottom. It should have been smaller than what was on the top. This number is smaller than our 4,000, which means it is reasonable for an answer. Okay. Says Mayor Hernandez conducted a random survey of 200 voters and found that 135 approve of the job she's doing. If there are 48,000 voters in Mayor Hernandez's town, predict the total number of voters who approve of the job she's doing. Okay, so we're setting this up with the two labels. Okay, it looks like we've got 200 voters and we've got 135 who approve. Okay, so let's set that up. Voters here, or total. And then this part is the voters who approve. Okay, it says 200 voters, that goes on the top here. It says 135 with the approved section. And over here we've got 48,000 voters, so that part just goes on the top, because it doesn't tell us anything else, and we want to know how many approve, so that's our X. Okay, we're going ahead and setting this up, same process as last time. 200 gets multiplied times the X, and we're setting it equal to the 135 times the 48,000, which gives us 6,480,000. Okay, then we can divide that by 200. To get 32,400. And we're making sure it's reasonable. Okay, that number is smaller than 48,000 like it should have been. Okay, so we can go ahead and finish this out. Voters approve. Alright, a couple more here. Says, if 3 DVDs cost $44.85, find the cost of 1 DVD. Okay, so this one, very straightforward. There's not a lot of math to it, but I want you to set this one up. See if you can solve it. Pause that video for me, please. Okay, this one you wouldn't have necessarily had to set up a proportion for because it is straightforward, but I do want to show you how it works. Okay, we've got DVDs and cost as our two things being compared. So 3 with the DVDs, $44.85 with the cost. And we want to know 1 DVD is what cost. So we've got 3x equals 4485. Okay, a lot of us would have said if 3 costs this, we just have to divide that by 3. That's what this math says, divide that by 3. Okay, so that's showing you that proportion does really the same thing there for you. 44.85 divided by 3 gives us a cost of $14.95 for a CD. Alright, last one here. The ratio of underclassmen to upperclassmen at Hays High is 6 to 5. If there are 498 underclassmen, how many students go to Hays High? Okay, so this one's a little bit of a different problem. They give us a ratio instead of us being given regular numbers. So that means it's probably asking for us to do something different as well. So let's look at the question first. It says, how many students go to Hays High? Okay, so that's important. How many students go to Hays High? This is a total. Okay, it wasn't part of our ratio because this ratio went with our underclassmen, and this one went with our upperclassmen. Okay, but here's our total for the underclassmen. So this is going to actually be a two-step problem. Okay, because we are given the underclassmen and we're given the ratio, we can find the upperclassmen, and then if we know that value, we can find the total. Okay, so the two labels dealing with the numbers we were given here were underclassmen and upperclassmen, so that's how we're setting it up. Okay, so that is 6 to 5. And over here, 498 went with the underclassmen. So we're going to put an X here. Even though that's not what it's asking for, we do need to find it to be able to solve. Okay, so setting this up, we've got 6x equals, okay, we're taking our 498 times 5, that's 2490. And then we're dividing by 6 to get how many upperclassmen there were, and that's 415. Let's go ahead and add a label to that. Okay, but if it wants the total, all we have to do is add that to our original 498 who were the underclassmen. Go ahead and write this out so you don't forget where it came from. And then we'll go ahead and just add those together to get our final answer. So take that plus your 498, and we have 913 total students. And that's it. Alright, please, if you have any questions while you're working on your homework, reach out, come see me.